welcome to Defy Robotics. Now, you just saw the synchronization of our swarm of 24 artificial fireflies. Each of these artificial fireflies consists of a knockoff Arduino Mega, powered over USB, and connected to its immediate neighbors over serial communication. In addition, each firefly has a red LED encased in a ping pong ball to give a visualization of the algorithm as it progresses.
So, our project is primarily inspired by the fireflies themselves. So, certain species of fireflies are able to synchronize across large areas while only being able to view their nearby neighbors, which is much more impressive than it may seem.
In addition, we were inspired by swarm robots and how really simple modular pieces can come together to create much more complex behaviors. Now, when we were programming these fireflies, each module was programmed from the perspective of a firefly itself.
So, it's currently unknown exactly why fireflies synchronize. However, the leading theory currently is that they synchronize for the purpose of mating. It's also important to note that fireflies have that limited visual range, so because of that, they can only view a few nearby fireflies, rather than the entire swarm itself.
Now, to show you how it all works. So, imagine you're a firefly. As a firefly, you're likely to blink. And as we see on the timeline, we'll let a blink denote the start of the period. Now, as Ben mentioned, fireflies have a rather limited visual range, so despite being part of a much larger swarm, you're likely only going to be able to see your immediate neighbors. So, after a brief delay, your neighbors blink. Three bars for the three fireflies. Now, the next time you blink, you decide you want to blink with your neighbors. So, you can accomplish this by taking one jump from where you were to somewhere around the average of all the blinking. Alternatively, you could take several smaller jumps to reach the same position. Now, imagine that every single firefly in this swarm is doing this whole process every time they blink. Now, that is how a large swarm of fireflies can approach synchronization through only local observation.
So, since fireflies synchronize so fast, we decided to test which algorithm would be the fastest. So, to start off, our preliminary data included a single leap from the firefly's blinking time to the average of itself and its neighbors, half of that distance in 2 leaps, 1/3 leap, and 1/4 leap. So, as you would probably expect, a single leap was by far the fastest. However, it had the fatal flaw of entering infinite loops, much more than expected. So, in these cases, the fireflies would go back and forth between 2 values while never actually synchronizing. This happened 10%, or 3 of our 30 trials, where they could not actually synchronize. This, although fast, was not very robust, which is why we like the algorithm of a 1/2 step. Although slightly slower and not quite as efficient, it's very robust because it never goes into those infinite loops, because it only goes part of the way there.
Look for our next videos where we go more into the coding and the engineering behind our system, and we look at the biological implications of our model. Thank you, and see you next time on Defy Robotics!